Good morning, everyone. Welcome to our lesson today. I'm Miss Barnes, and this is math for kindergarten through second grade. Today, we're going to work on adding within 10. That means the sums of our problem will not be larger than 10. Our lesson objective today is I can use addition to solve real-world problems. And as we're working today, we're going to need a couple things. First, we're going to be using snap cubes. Now, you probably don't have snap cubes sitting around at home, and that's okay. If you don't, you can use any materials, objects, or toys that will help you count. Second, we're going to be using a part whole map. If you don't have a part whole map, I'm going to show you how to make one. Take any piece of paper that you have and fold it in half horizontally. So your paper is horizontal, and then you'll fold it in half and crease it. And then what I do is I take a black marker, and on that center crease, I'm just going to draw a black line. Now, it's okay if it's not perfect. You'll see that mine's not perfect. But it's important here that we have two distinct sides so that we can separate the objects that we're counting. So if you don't have a part whole map, that is a quick and easy way to make one. And just again, if you don't have snap cubes at home, that's okay. Find something to help you count. Maybe grab some of your blocks or some of your toys, maybe your action figures, and we can use those in this map also. Okay? So, just as a reminder, you need something to count with, a part whole map, and a pencil or something to write with. So take a quick second and let's get ready to learn. Let's get started. Here's our first problem. It reads, the pet rescue has 3 rabbits and 4 cats. How many pets does the rescue have in all? So what do you think is the first step to figuring this out? Remember I told you that we'll be working with snap cubes and this part whole map that you see on the right side of your screen. The first thing we'll do is pick a color of snap cubes to represent the rabbits. I picked green. Then we'll do the same thing for the cats. And for the cats, I picked the brown ones. So the first thing we should do is we need to model 3 rabbits and 4 cats in our map. So on the left half, I'd like you to place 3 objects. 1, 2, 3. And do you remember how many we need on the right side of the map? That's right, we need 4 because the rescue has 4 cats. So let's put those in. 1, 2, 3, 4. So here we have modeled 3 rabbits and 4 cats. But the question for our problem is how many pets does the rescue have in all? Well, how do I figure that out? Do you know? I bet I can guess. It's the opposite of subtraction. We're going to use addition to solve this problem. So the first step in writing an addition problem is writing down the numbers that we have of the objects. My addition sentence is 3 green cubes plus 4 brown cubes. But that still doesn't answer the question yet, because we need to find out how many there are total in all. So let's count the green cubes and the brown cubes together. Are you ready? 1, 2, 3, 4, 5, 6, 7. So how many cubes do we have in all? That's right, we have 7 cubes. But does that answer the question? Because the question says, how many pets does the rescue have in all? So what should our answer for the addition sentence be? That's right. It should be 7 pets. How did you do? I bet you did great. Let's try the next one. Our next problem is about baseballs and basketballs. Do any of you play sports? I love the summer because we get to go outside and play sports. My favorites are softball, and I really love fall for football. So today we're going to talk about a box that's holding baseballs and basketballs. And this box is holding 5 baseballs and 3 basketballs. How many balls are in the box? Well, what's our first step? That's right, we have to pick colors for the cubes. I picked red for the baseballs and orange for the basketballs because they kind of match. Can you tell me the next step? That's right. We have to model 5 baseballs and 3 basketballs in our part whole map. So on the left half of your part whole map, I'd like you to place 5 objects that represent the baseballs. Let's count them together. Are you ready? 1, 2, 3, 4, 5. Did you get 5 on your map? Great. Let's move on to the basketballs. How many basketballs did the problem say we needed? You guessed it, we need 3. So on the right half of your part whole map, I'd like you to place 3 objects that represent the basketballs. We'll count my cubes together. 1, 2, 3. Make sure your part whole map matches mine. You should have 5 objects on the left half and 3 objects on the right half. Does this answer our question? Are we finished? No, we're not. We have a question to answer, and that question is how many balls are in the box? That means we have to add the baseballs and basketballs together. Are you ready to try that? Can you first write an addition sentence that models your part whole map? What would you write for your addition sentence? I'll show you what mine looks like. Mine says 5 red cubes plus 3 orange cubes equals, well, how many? How many does it equal? Can you count all of the cubes in my part whole map together? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 balls in the box. Did you get it correct? Great job. Now you might be thinking, Miss B, my part whole map is backwards. I put the 3 basketballs on the left and the 5 baseballs on the right. That's okay. As long as your model matches your addition sentence, that's what matters most. This also here on the left side with the red cubes will eventually be recognizable as 5. Today we counted them, but next week we might not. So make sure you're practicing reading different variations of models of numbers so that you can always recognize the ones that you see in front of you. Now the last problem we're going to work on today is a challenge for you to try at home. Are you ready to see it? Your problem says, Jen finds 2 leaves on the ground. Then she finds 5 more leaves. How many leaves did she find? So I'm going to give you some time to work on this. and then we're going to come back and review the answer together. Are you ready to review? So Jen first found 2 leaves, and then she found 5 more leaves. If you said she found 7 leaves altogether, you're correct. Great job. If you didn't get the answer correct, that's okay. Just make sure you go through the problem and check your math. It's really important to go back and figure out where we made mistakes so that we can get better next time. That's all for today, friends. Let's have a quick review. Today we talked about adding within 10, and our objective was I can use addition to solve real-world problems. Remember, you don't have to be sitting at a table to practice your math. As you're out and about this week, walking, observing, you can count and add things all around you. As you're working this week, I would love to see everything that you're working on. If you would like to share something with me, you can find me on Twitter at MissB_KCPS. I'd love to see the work that you're doing. It was my pleasure having you in class today. I'm Miss Barnes, and I'll see you next week.
Good afternoon, boys and girls. This is Miss Shields from Faxon Elementary. Today I am here to help you with adding and subtracting fractions with unlike denominators. Let's go ahead and get started. You will see on my screen that I have 5 simple steps that you can use in order to help you with these types of problems. Feel free to write them down so that you can go back and reference them in your notes later. Step number 1, we are going to read the problem. Step number 2, write out the problem. Step number 3, find the LCD, or least common denominator. Number 4, rewrite and solve the problem. Number 5, simplify if it is needed. So we're going to start back up here at step number 1, and we're going to read the problem. Yesterday, Carson threw away 1 1/3 pounds of paper packaging. He also threw away 3/4 of a pound of plastic packaging. Altogether, how many pounds of packaging did Carson throw away yesterday? I have to ask myself, what is this asking me to find? In this case, it is asking me to find out how many pounds of packaging Carson actually threw away. This word all together means we have to combine things together. We're putting them all together. And what are we putting together? We are going to put together the 1 1/3 pounds of paper that he threw away and combine that with the 3/4 of a pound of plastic he threw away. So we are ready for step number 2. We're going to write out that problem. So I'm going to write our problem. We're going to have 1 1/3 and since we are going to combine it, that means we're going to add. So we're going to add 3/4. I'm giving myself plenty of room so that it is easier for me to work out our problem and things aren't all bunched up together. Okay. The next thing we're going to do is find the LCD, or the least common denominator. So in that case, we're going to keep a list over here of our least common denominators. And the denominators that we are working with is a 3 in 1 1/3 and a 4 in 3/4. So we are going to find the least common denominator of these two numbers. And we do that by skip counting. So I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21. And then down here, I am going to count by 4s. 4, 8, 12, 16, 20, 24. So now we need to look at this and decide which one is the smallest one that they have in common. So I always like to start with the bigger of the two numbers and use those multiples first. So we have 4. Do you see a 4 up here? I do not see a 4. Then we have an 8. Do you see an 8? We have a 12. Do you see a 12? Of course. And so 12 is going to be our least common denominator. We are now going to use that 12 and go to step number 4 and rewrite our problem. So we have to rewrite our problem using 12 as a denominator. So my problem is now going to read 1 and something over 12. And this one will read something over 12. So now we need to decide, what is that something that goes there? So I look and I have to decide 3 times something equals 12. I can go back over here and decide it's 1, 2, 3, 4. 3 times 4 is 12. And if I multiply the bottom denominator by 4, I have to multiply the numerator by 4. 1 times 4 is 4. Now we follow that same step over here and decide 4 times something equals 12. 4 times what equals 12? 1, 2, 3. 4 times 3 equals 12. And whatever we do to the bottom, we must do to the top. Very good. 3 times 3 is 9. We have now rewritten 1 1/3 as 1 4/12 and 3/4 as 9/12. We can now solve that problem by adding them together. First thing I need to decide is I have a whole number here of 1. I do not have a whole number. So this is the same thing as 1 plus 0. And 1 plus 0 is 1. And then we have 4 plus 9. 9 plus 4. That equals 13. And my denominator is going to stay the same since we found a common denominator. And my denominator will still be 12. Step number 5 is to simplify if we need to. We know that we need to simplify this problem because it is an improper fraction. Our numerator is larger than our denominator. So I have to think about how many pieces made up my whole. And we said 12 pieces made up a whole. If I had 12 out of 12 of them, then I had one whole. If I have one whole here, and I have one hole here, I am going to be left with 2 holes. But how many do I have left here? Well, 13 minus 12 is 1. So I have 2 and 1/12. I'm going to show you what this looks like when we are using fractions. Fraction strips. So on here I have fraction strips that are divided into 12 pieces. I'm going to go ahead and I'm going to color in that 1 4/12. One whole, so I'm going to color in the whole thing. And then I'm going to shade in 4 out of 12. 1, 2, 3, 4. We added to that 9/12. So 9 out of 12. So we're going to count 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. You now see that what I have shaded is 2 holes and 1 out of 12, or 1/12. So I have 2 and 1/12. Which is what we got here as our answer. So we did a very nice job following those steps. We're going to see if we can follow those steps again, and this time we're going to try to work through a subtraction problem following our steps. So step number 1, we're going to read the problem. Mike has 1 5/12 books left to read for a school project. Mike read 1 1/9 books on Sunday. How many more books does Mike have to read? Again, we ask ourselves, what are we trying to find? In this case, we're trying to find how many more books does he have to read? How many more means that he read some, but he still has some more that he needs to read. So he has to read 1 5/12. He has already read 1 1/9. We need to use those 2 numbers to decide how many more does he need to read. So we're going to write out our problem. We're going to start with 1 5/12. That's how much they said he has to read for his project. But he has already read, so we're going to take away what he already read, and he already read 1 and 1/9. So our problem now is going to be 1 5/12 minus 1 1/9. We're going to find that LCD, or that least common denominator. What are the denominators that we are going to use? I see we have a 12 and we have a 9. So we are going to skip count by 12s. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. So now we have a list of our multiples. Now we need to find which one do they have in common. What is the smallest one they have in common? Since 12 is our bigger number, we're going to start with the 12. Do we have a 12 in this row? No. Do we have a 24? No. Do we have a 36? Yes, we do have a 36. So 36 is going to be our LCD, or least common denominator. So we need to rewrite our fractions using 36 as our denominator. I didn't leave myself enough space on this one, so please make sure you're leaving yourself some room when you are solving these problems. So 12 times what equals 36? We go right back over here. 1, 2, 3. 12 times 3. Whatever we do to the bottom, we must do to the top. So 5 times 3 is 15. 9 times what is 36? 1, 2, 3, 4. 9 times 4. What I do to the bottom, I have to do to the top. 1 times 4 is 4. Now we are ready to solve that problem. We're going to subtract our whole numbers first. 1 minus 1 is 0. 15 minus 4. 15 minus 4 is 11. My denominator stays the same, so I have 11 36ths of a book left to read. If we go through and we look at that using our fraction strips, we had 1 whole, that's the whole book that he read. And he had 15 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 36. Now he had already read 1 whole book. He had read this whole book. So he read all of this, and then he read 4 out of 36, and you'll see what he has left is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of that 36. So he had 11 36 remaining. 11 36. That is all I have for you guys today. Please come back and watch some more videos, and if you have any questions, let us know. Have a great day.
Hello, my name is Mary Jo Fender, and this is Math for Middle School. Today we're going to continue our lesson on powers and exponents, and we're going to learn how to write and evaluate those powers when they are in expressions. They're a little bit tricky, especially when we throw in negatives into the combination. Grab your supplies, paper, pencil, and a good attitude, and get ready to learn. Last week we talked about powers, and as you can see, 3 to the 4th power in its entirety is called a power, and it has 2 main parts. The 3 represents our base, and our base is the factor that is going to be multiplied repeatedly, and the 4 tells us how many times that factor is going to be repeated. So if we think of 3 to the 4th power in expanded form or repeated multiplication, it's going to look like 3 times 3 times 3 times 3. Now, when we want to evaluate or to find the product of this power, we're going to multiply. Now, you can use order of operations and work left to right, or you can use associative property and group them together. Now, you're going to be grouping, that's the easiest way for me. So if I group the first pair of 3's together, 3 times 3 is 9. And the second group of 3, 3 times 3 is also 9. And then we're going to group the product of those 2 together. So 9 times 9 is 81. So when we are evaluating, we're looking at how many times we are multiplying that base. And remember, the exponent tells us how many times that factor is going to appear in our repeated multiplication. So let's continue. So what if we have a negative? Negatives are tricky for a lot of people, and really they're just a way to say opposite. So if you look at our first term, negative 2 to the fourth power. Now you are going to notice that negative 2 is in parentheses, and it tells us something special. It tells us that our factor is negative 2, and we're going to use that in our repeated multiplication. Now notice our exponent is 4. So that tells us that factor is going to appear 4 times. So how that looks in repeated multiplication is negative 2 times negative 2 times negative 2 times negative 2. Now you notice I lost the multiplication symbol in this. And the reason I can lose that is because parentheses, as they are stacked as you see, mean multiplication. Now also, negatives appear a lot of times in parentheses, and the reason for that is they don't want you to miss those negatives. Negatives are one of those things that lots of people have a tendency to forget about because sometimes they look like subtraction, especially when you have 2 together. So be careful, don't lose those negatives. We're going to use associative property again, and we're going to group the first couple of 2's together. Negative 2 times negative 2, well, 2 times 2 is 4. Remember your integer rules, negative times a negative is a positive. So the product of the first 2 factors is going to be 4. I'm going to group the next 2. Again, they're the same, so I know that is also 4. And then I can just multiply 4 times 4, and that's going to be 16. So notice, in my original expression, I have a negative. But because I have an even number of negatives, my answer or my product is going to be a positive. Now let's take a look at our second term. And this term, notice, doesn't have any parentheses. And what that tells me is that 4 is only going to be with the 2. So my power here is actually 2 to the fourth power. This negative tells me whatever that product is going to be its opposite. Now here is where your negative could get lost if you're not careful. So what would this look like as repeated multiplication? So I'm going to hang on to my negative, but notice I'm going to put my repeated multiplication inside the parentheses. I'm going to do that first, and then whatever my answer is or my product, I'm going to add or apply the negative because that negative means opposite. So again, I'm going to use associative property. 2 times 2 is 4. Second group, 2 times 2 is also 4. I'm going to hang on to my parentheses. Don't want to lose that because that means I could lose my negative. 4 times 4 is 16. I'm going to bring that negative down. So my answer for negative 2 to the fourth power is negative 16. Notice how from example 1 to example 2, how the parentheses play a very important part. I've seen lots of students work through their problems, get everything right, then at the very end, they either lose or misplace or misrepresent their negative, and all their hard work is for naught. So be careful, where are those parentheses and how do they apply to the problem? So let's take a look at some practice problems. Notice I have 2 at the top that have parentheses, 2 at the bottom do not. So let's take a look at the first one. So I have negative 7 to the second power. Notice my -7 is in parentheses, so that is going to be my factor that I'm going to use for repeated multiplication. I always like to write it out in expanded form so I can see what I'm multiplying. As you progress and get better, you're going to memorize some of these basic terms, okay? So let's take a look at some practice problems. So our first one is -7 to the second power. Notice the -7 is in parentheses, so that tells me that the factor itself is actually negative. And when I write it in repeated multiplication, I'm going to be writing -7, -7. So it's going to look like this. So -7, I'm going to go ahead and put it in parentheses so I don't lose that negative. And then because my exponent is a 2, I'm going to write the factor twice. So repeated multiplication would be -7 times -7. Well, 7 times 7 is 49, and my integer rules say that a negative times a negative is a positive, so my answer to this particular problem or expression is going to be 49. So let's take a look at another one that has parentheses. -2 is in parentheses to the third power. You would read it -2 to the third power. Notice my exponent is 3, so I'm going to write -2 3 times in my repeated multiplication. So I'm going to say -2, don't forget those parentheses, -2. Now, I'm going to go ahead and use my strategy of grouping my multiplication in groups of 2. It's much easier for me. So my first group of 2 factors, -2 times -2, negative and a negative make a positive, 2 times 2 makes 4. So now I'm going to bring down my third term. So now I have 4 times -2. Well, a positive times a negative is going to be a negative. 4 times 2 is 8. So the product of the power -2 to the third power, written with the -2 in parentheses, is -8. Now, the bottom two are a little tricky, and I always see students not paying attention to the fact that they don't have don't have parentheses. So notice my power here is actually 3 to the third. Once I have that answer, that product, I'm going to make it the opposite or add a negative to it. So the way I would write repeated multiplication, 3 times 3 times 3. Go ahead and group. 3 times 3 is 9. Bring down my extra 3. 9 times 3 is 27. Remember that negative, so my answer is negative. Now, another way you could actually do this in expanded form and kind of keep it the same thought process is if you put the negative and then your expanded power within parentheses. That would remind you that, hey, I need to multiply that power first and then add that negative at the end. Again, you would do the same type of work, except this time just bring. So let's look at a second way to write this problem. I think it's a lot better because the product or the repeated multiplication is in a set of parentheses, and I don't think you lose your negative as easily. So the way that would look is you're going to put your negative and your left parenthesis, and then you're going to say 3 times 3 times 3, close it with your right parenthesis. Now, order of operations says what I do inside the parentheses is my first step. So I'm going to multiply 3 times 3, that's 9. I'm going to bring down that extra 3 that I still have. Make sure you enclose that in parentheses and add your negative. Now all we have to do is multiply 9 times 3, which is 27. All of my steps are done within that parentheses, so I can just leave it off now and add my negative. I've been keeping track of that negative all the way through my steps, and I'm less likely to lose it. So let's take a look at our fourth example. We have -4 to the third power. So remember, because my -4 is not in parentheses, my power only applies to my 4. So I'm going to go ahead, use my parentheses strategy. I'm going to put my negative, and then inside my parentheses, I'm going to put my repeated multiplication. And the factor I'm going to repeat is 4. So I'm going to say 4 times 4 times 4. I'm going to do what's inside parentheses now. So 4 times 4 is 16. Bring that extra 4 down that I haven't worked with yet. Don't forget my negative. So 16 times 4 is 64. I've completed my multiplication, so I don't have to keep writing my parenthesis, and I can go ahead and put a negative. So my answer, or my product of -4 to the third power, is -64. Now let's take a look for when a power has a base of a fraction. For some reason, people always say fraction, they all tense up, and everything that they learn seems to just go out the window. Everything is still the same. The base hasn't changed. It's still the same process. What the exponent does is still the same thing. So in this particular case, our base is 2/3. So that is going to be the factor that we're going to multiply by. Now, notice 3 is our exponent, so that tells us how many times the factor 2/3 is going to be multiplied. So how that would look in repeated multiplication is 2/3 times 2/3 times 2/3. Now, because I don't have a negative, I'm not going to write parentheses. I think it's too much information right now. It's just that little dot does me good for my multiplication. Now I have to remember my fraction rules. So when I'm multiplying times a fraction, so I'm going to break this problem apart into 2 parts. So for today's lesson, writing and evaluating powers and exponents within expressions doesn't have to be that hard, especially when you have negatives involved. So just remember, powers is the term, base is what you're going to be multiplying by, and your exponent tells you how many times that factor is going to be multiplied. Thank you for joining me today, and I hope you have a great experience. Keep practicing for math. You're going to get better, I know it. My name is Mary Jo Fender, and I'll see you next week.
Hello, my name is Marcelina Lirius, and welcome to Math Monday. Our lesson for today is solving linear equations. You will need your pen, your paper, and if you have a calculator, that would be helpful. When you're ready, let's get started. Last week, we learned how to solve literal equations. A linear equation is an example of a literal equation that has 2 variables, x and y. The standard form of a linear equation is ax plus by equals c. If you remember, last time we solved this equation for y in terms of x. And we arrive at this equation, y is equal to -ax over b plus c over b. These two are equivalent. This is the standard form, and this is the slope-intercept form. Sometimes this is represented as y equals mx plus b, where m is the slope and b is the y-intercept. At the end of this lesson, you should be able to graph 3, 2. At the end of this lesson, you should be able to solve and graph linear equations. So how do we find and interpret solutions to a linear equation? A solution to a linear equation is an ordered pair x, y that satisfies the equation. Meaning that if we substitute these values for x and y into the equation ax plus by equals c, we arrive at a true statement. Graphically, these solutions are points on the graph of the equation. They are points on the line. Okay, so if this is the graph of a linear equation, so all points here are solutions to the equation of this line. Let's try the first example. We are asked to determine if the given ordered pair x and y is a solution to the equation 3x plus 4y equals 20. Okay, so we are going to substitute these values for x and y, 0 and 5, to the equation 3x plus 4y equals 20. Okay. Be ready with your pen. Let's do this together. Let's try the first example. We are asked to determine if the given ordered pair xy is a solution to the equation 3x plus 4y equals 20. So we are going to substitute the values of x and y. In this case, our x is 0 and y is 5. So let's substitute this into the equation 3x plus 4y equals 20. So 3 times x, which is 0, plus 4 times y equals 5 equals 20. So this is 0 plus 4 times 5 is 20 equals 20. So this is a true statement, and we say that the ordered pair is a solution to the equation. The interpretation of this is, when we plot the point 0, 5, this point lies on the line. Let's try the second example. So is the point 1, 3 a solution to the equation? So let's substitute. When x is 1, so 3 times 1 plus y is 3, so 4 times y, and this is 3, equals 20. So this is 3 times 1 is 3, 4 times 3 is 12 equals 20. So 15 is not equal to 20. So this is a false statement. So we say that the point 1, 3 is not a solution, meaning this is not a 3, 2, meaning this point does not lie on the line or the graph of 3x plus 4y equals 20. Okay, I want you to try the next example or the next point. See if this is a solution. Try this on your own. Okay, let's see what your answer is. Okay. Let me erase this portion. So we said that this is not a solution because we arrived at a false statement. Now let's see if you arrived at the same answer. So if we substitute our x and y, when x is 4 and y is 2, so we have 3 times x. Our x is 4 plus 4y. Y is 2. Will this be equal to 20? So 12 plus 8, 4 times 2 is 8 equals 20. And if we add these two numbers, this will give us 20 equals 20. So our conclusion is the point 42 is a solution to the equation 3x plus 4y equals 20. And graphically, we say that this point lies on the line or on the graph of the equation. I'll give you time to take down notes. Okay, in the next example, we are asked to find ordered pairs, two ordered pairs x and y that are solutions to the equation negative 5x plus 2y equals 12. Unlike the first one, when we were given the points to check if their solution, this time we are to find ordered pairs that will satisfy the equation. Okay, so let's see if 3, 2. Let's try x equals 0, 3, 2. Let's try x equals 0 and solve for y. Okay, so when x is 0, let's substitute this into the equation. So negative 5x, our x is 0, plus 2y, we're looking for y, equals 12. Can you follow? Okay, so simplifying, this part here is 0. 5 times 0 is 0, plus 2y will give us 2y on the left side equals 12. Using inverse operations, we divide both sides by 2. Again, by inverse property, 2 over 2 is 1. And 1 times y will give us y. Then 12 over 2 is 6. Okay, so we say that when x equals 0, y equals 6, the point 0, 6 is a solution. This means that this point is on the line or is on the graph of negative 5x plus 2y equals 12. I'll give you time to process and take down notes. So let's find another ordered pair. So if we have, let's say, x equals 2, let's find the value of y. Again, let's substitute x equals 2 into the equation, negative 5x. So when x is 2 plus 2y, we're solving again for y here, equals 12. Okay, that's the substitution part when x is equal to 2. Let's simplify. Negative 5 times 2 will give us negative 10 plus 2y equals 12. Then let's solve this two-step equation. Let's eliminate negative 10 by adding its inverse, so plus 10 on both sides. This is justified by the addition property of equality. Then this is 0 here, giving us 0 plus 2y is 2y equals 12 plus 10 is 22. Again, by inverse operations, let's solve for y by dividing both sides by 2. 2 over 2 is 1 times y is y equals 11. So when x is 2, y equals 11. So if we write this as an ordered pair, okay, always write the x value first. This is a common error. So you always write 2 or the x value first, then followed by the y value, which is 11. This ordered pair 2, 11 is a solution to the equation. And if we plot these points, both of them are solutions. This means that both of them will lie on the same line. Pause. So now we're ready to graph the equation 3x plus 4y equals 20. So remember, in our first example, we found out that the point 0, 5 was a solution, 1, 3 was not a solution, and 4, 2 is a solution. Now let's graph the equation 3x plus 4y equals 20. So in our first example, we found out that 0, 5 and 4, 2 are solutions to the equation. So if we plot these points 0, 5 and 4, 2, these are solutions, so they will both lie on the same line. Okay, solutions 4, 2 and 0, 5, they lie on the same line. And the point 1, 3, we said that this is not a solution. So when we graph 1 and 3, notice that it's outside the line. It's not on the line or not on the graph of 3x plus 4y equals 20. That concludes our lesson for today, and I will see you next week.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.